Welcome to The Explainer. Today, we're building a fortress. Literally, a digital fortress around your Microsoft 365 email domain. If you manage email, well, you already know the stakes, right? Spoofed senders, business email compromise, phishing attacks, they are relentlessly knocking at the gates. We're going to untangle the alphabet soup of email authentication so you can secure your domain without accidentally breaking your legitimate mail flow. It requires a layered approach, and we're going to walk through exactly how to set up those defenses based on the source material we've pulled together.
Okay, let's dive into this, because this specific question agitates almost every IT admin I talk to. You've done the hard work. You published a strict DMARC reject policy. You explicitly told the entire internet, hey, if an email doesn't securely originate from my domain, block it. Yet somehow, spoofed emails are still slipping through and landing right in your users' quarantine folders. And once it's there, they can still see your brand name and maybe even click release. So why on earth is that happening?
Well, here is the incredibly uncomfortable truth from our sources. Your DMARC policy, it's essentially just a request. Ultimately, the receiver still owns the final delivery decision. They weigh their own spam models, their spoof intelligence, and their local allow lists heavily over your domain policy. So a reject policy absolutely reduces abuse, but it doesn't guarantee invisible abuse, especially depending on how the receiving Microsoft 365 tenant is actually configured.
To systematically rebuild our email defenses, here's our roadmap for this explainer. First, the DMARC quarantine conundrum. Second, DKIM digital signatures. Third, DMARC as the policy enforcer. Fourth, configuring ARC for the middleman. And finally, the gradual rollout playbook.
All right, let's jump into Section 1, the DMARC quarantine conundrum.
So, why doesn't reject always guarantee invisible abuse? The core issue here is that local overrides can absolutely bypass DMARC, and a quarantined email still creates a user-facing artifact of your brand. But hey, before you panic, you've got to confirm what you're actually dealing with. Is it real spoofing, where they hijacked your visible domain? Or is it just display name impersonation, where they literally just typed your company's name in the sender field? If you happen to administer the receiving Microsoft 365 tenant, the fix is right in your anti-phishing policy. Just set sender p=reject failures to actually reject, not quarantine. Now, if you only own the sending domain, your job is a bit different. You need to keep your own sources completely clean, prove the abuse using message headers, and then escalate that to the recipient's IT team.
Moving right along to Section 2, DKIM, the digital signature.
If securing your email is like building a fortress, DKIM is basically the unforgeable royal wax seal on your outgoing messages. DKIM, which stands for Domain Keys Identified Mail, uses cryptographic private and public keys. It's brilliant, really. The source system uses a private key to digitally sign your outbound message. Then the corresponding public key is stored securely right in your domain's DNS records. When the receiver gets the email, they check the DNS, grab that public key, and verify the signature. If the seal is broken, no way are they letting it through, because they know the message was altered in transit.
But here's the catch. How you set this up in Microsoft 365 is absolutely critical. We've got a comparison here. The correct setup uses CNAME records. This is vital because CNAME delegates key management and seamless key rotation directly over to Microsoft's infrastructure. The incorrect setup, which honestly so many admins mistakenly try, uses TXT records. Using TXT records requires manual key management and is actually completely unsupported for Microsoft 365. Seriously, don't create a massive configuration headache for yourself. Just use CNAME.
Now, what's really interesting about this slide is the specific formatting gotchas that trip up even seasoned IT admins. First off, always retrieve the exact target values from the Defender portal. Don't try to guess the formatting. Second, when you're entering your host name at your DNS provider, usually you only enter the subdomain portion, like selector1_domain key, because a lot of providers automatically append your main domain for you. If you type the whole thing out, boom, you get a double domain error. And finally, always create both selector1 and selector2 CNAME records. Even though only one is active at a time, Microsoft absolutely needs that second one ready to go so they can securely rotate your cryptographic keys in the background.
Let's move on to Section 3, DMARC, the policy enforcer.
So if DKIM is our wax seal, DMARC is the gate guard who meticulously checks both the seal and the guest list. DMARC stands for Domain-Based Message Authentication, Reporting, and Conformance. It does something incredibly important. It checks for alignment. Basically, DMARC validates that the domain in the hidden envelope sender address, which is what SPF checks, or the domain in the DKIM signature perfectly aligns with the visible from address that your user actually sees sitting in their inbox. A message is only going to pass DMARC if at least one of those, SPF or DKIM, passes and it perfectly aligns. Let's look at the difference between relaxed and strict modes in practice, because it's a real game changer. Take a look at that second scenario. The visible from address is contosa.com, but the underlying system is using a subdomain, bounces.contosa.com. Now, under a relaxed policy, this passes with flying colors because the root domain matches, but under strict alignment, it fails entirely because the domains aren't an exact perfect match. Unless you have a super specific security requirement, our sources highly recommend starting with relaxed alignment. Otherwise, you're going to break legitimate mail sent from your own subdomains.
And listen, setting up DMARC isn't just about blocking bad guys, it's about visibility. Your DMARC TXT record must include reporting tags. You use the RUA tag to receive daily aggregate reports. These are XML files that show you broad trends in literally every IP address trying to send mail on your behalf. Then you use the RUF tag for immediate forensic reports, which give you near real-time details when a specific message fails authentication. Reporting is simply non-negotiable if you actually want to know who is impersonating you out there.
Next up, Section 4, ARC, trusting the middleman.
So, what happens when our carefully laid defenses are accidentally tripped up by a friend? Well, that is exactly where ARC, or Authenticated Receive Chain, comes in. Think of it as a trusted courier network. Sometimes legitimate email services, like a standard mailing list or an inbound security gateway, they need to modify a message's header or body before delivering it to your Microsoft 365 tenant. But by modifying the message, they accidentally break our perfect DKIM wax seal. ARC steps in to preserve the original email authentication results across these legitimate intermediaries.
Chronologically, here is exactly how legitimate forwarders cause a headache. Step 1. The original sender dispatches an email, perfectly signed, easily passing SPF and DKIM. All good. Step 2. The email hits a middleman forwarder. That forwarder helpfully adds a caution external tag to the subject line, or maybe tweaks the body. Boom, the cryptographic seal is now broken. Step 3. The final receiver evaluates the email, sees a broken signature, misaligned IPs, and fails the DMARC check. Suddenly, a perfectly legitimate email is sent straight to the junk folder.
The solution to this is simple, but it's absolutely essential. You've got to go into the Microsoft Defender portal and add that intermediary to your trusted ARC sealers list. When Microsoft 365 sees mail arriving from a trusted ARC sealer, it will look at the ARC headers, see that the email originally passed authentication back in Step 1, and basically use that original pass to override the current DMARC failure. Magic.
Which brings us to our final section, Section 5, the gradual rollout playbook. So, the crucial point is you cannot just flip a switch to full enforcement, or you are literally going to block your own organization's emails. You must follow a safe, step-by-step strategy. Step 1. Start your DMARC policy at P equals none. This does absolutely no blocking. It purely turns on the reporting, so you can just sit back and monitor your traffic. Step 2. Once you've fixed any misconfigurations you find, move the policy to quarantine, but use the percentage tag to slowly scale it up. Affect only 10% of failing mail, then 25%, and so on. Step 3. Only enforce full P equals reject once your aggregate reports prove, without a doubt, that 100% of your legitimate mail sources are signing properly.
Our sources also share a few awesome best practices from the trenches for this rollout. First, separate your marketing mail from your corporate mail using subdomains. This really limits the blast radius if a bulk mailer accidentally misconfigures something. Second, prioritize DKIM signing over SPF for forwarded mail. Why? Because SPF easily breaks during forwarding, whereas DKIM survives as long as the body isn't modified. Third, fix your website's contact forms. Don't let your web server send an email to you claiming to be from the visitor's email address, or your own DMARC policy will block it. And finally, maintain an active, ongoing review of those aggregate reports. And here is a highly specific but very important technical detail. When you're setting up your DKIM CNAME records in your DNS, make sure to set the time to live, or TTL, to at least 3,600 seconds. That's exactly 1 hour. If you set this too low, receiving servers are going to query your DNS way too frequently. That leads to intermittent lookup timeouts and some frustratingly random DKIM failures.
Which leaves us with this final question to ask yourself today. Go look at your Microsoft 365 environment right now. Is your email fortress actually rejecting verified threats, Or are your anti-phishing policies accidentally just hiding sophisticated spoofing right inside your users' quarantine folders, just crossing your fingers and hoping they don't click release? Now that you have the playbook for DKIM, DMARC, and ARC, it's time to find out. Thanks for joining me on this explainer. Keep learning and keep those domains secure.